Hello and welcome to Dr. T's Algebra 2. In this video we're going to be reviewing some pre-algebra, which shows up again in Algebra 2, Algebra 1 and Algebra 2. Laws of exponents. And so here we see all the laws of exponents for integer exponents. These should be familiar, so let's look at some examples. Number 1 isn't really an exponential problem. This is a combining like terms problem. We could say these have an exponent of 1, but we're adding terms, we're not multiplying, so we're not going to work with the exponents. 11 and 17 is 28, and then our x stays the same. In this example, we cannot combine like terms because we don't have like terms. We've got a 2 exponent and a 1 exponent, so we need to leave that. Number 3, we've actually got some exponents here, and so this is the product rule. When we multiply like bases, we just add the exponent. So that's a to the 7 plus 3, or a to the 10th. Next one, x squared y plus 5x squared y. Again, we're just adding like terms here. So 6x squared y. Exponents stay the same, coefficients change because we're adding there. Here we're multiplying. And so we can multiply both the coefficients and we can multiply the variables. 3 times 4 is 12. And then we're going to add exponents. 1 plus 2 is 3. In the next one, we've got like terms. We've got a in both terms here, and we're just multiplying, so we can combine all those a's and b's. We're going to get a cubed, which is 2 plus 1, and then b to the 5th, which is 2 plus 5. So when we're multiplying, then we're adding the exponents. When we divide, we subtract the exponents. And if we have coefficients like this one, we'll multiply the coefficients. 6 times 2 is 12. And then we've got 5m here and 1m there. That makes m to the 6th. N squared and n to the 9th, so that's n to the 11th. Next one, we are adding and subtracting, and so we can only combine like terms. We've got a to the 4th, b squared, c, and this one and that one, so we can combine those, and we get 16 minus 4 is 12. A to the 4th. B squared c. That's plus 5a b c. And again, we are combining like terms. We got a y squared here, we got an x squared here, we got an xy here, so that's as simple as it gets. And finally, we're adding and multiplying. So when we're multiplying, that's when we deal with the laws of exponents, multiplying or dividing, not adding or subtracting. We'll add or subtract exponents, not terms, not coefficients. So that's plus 4 times 5 is 20. And then we'll multiply that x to the 1st by x to the 1st and get x squared. And then we can just tack that y on the end there. Next one. Now we're dividing. 8 minus 3 is y to the 5th. 3 minus 6 is a to the negative 3. Or if we have a negative exponent on top, put it on the bottom. If we have a negative exponent on the bottom, we'll put it on the top. This negative sign is in front of the b, and so this is still going to remain b. This is like negative 1 times b to the 7th divided by b cubed, so b to the 7 minus 3, or b to the 4th. So negative b to the 4th. We got 2 down here and 4 up there. We can do a little bit of subtraction. If the bigger exponent is on the numerator, then the result will be in the numerator. If the bigger exponent is in the denominator, then the result will be in the denominator for the variable term. Here we're going to divide 10 and 2. We get 5. And then we're going to get rid of xy, get rid of that squared. So we're going to get 5x, not 5x, 5y. 10 divided by 2 is 5, x divided by x is 1, y squared divided by y is y. Next. You got 2 and 18, they share the highest common factor of 2, so we got 1/9. And generally speaking, we can get rid of that 1 on top. We don't need to have 1 up there. We know that 1 is our coefficient. We've got 1a on the top and 3 on the bottom, and so That means we're going to have a squared on the bottom. We've got a larger exponent of b on the bottom, so we're going to have b to the 7 minus 3, or b to the 4th, and sure enough, actually, we have 1 on top. It's just not as a coefficient. 16 divided by 4, we're going to have a 4 in the numerator. 16 is bigger, so our coefficient will be in the numerator. We don't have any x's on the bottom, so we'll put that x on top. We've got more y's on top, so we got y to the 5 minus 2, or y cubed. And then we have more z's on the bottom, so z to the 6 minus 4 is z squared. Next, 25 divided by 5 is 5. We've got r to the 6 on the bottom, r to the 5th on top, so we're going to end up with r on the bottom. And then we got s cubed up top, s on the bottom, so 3 minus 1 is 2. Highest common factor between 8 and 10 is 2, and so 8 divided by 2 is 4. 10 divided by 2 is 5. Got x cubed up top, x on the bottom, so 3 minus 1 is 2. Y to the 10th on the bottom, y to the 7th on top, 10 minus 7 is 3. And finally, 3 divided by 9 is 1/3. And again, I don't think we're going to need that 1. So we have our 3 on the bottom, m to the 7th minus 4. M to the 7th divided by m to the 4th is m to the 7 minus 4, m cubed. And then we got just n and n on the bottom. So m cubed over 3. And that is the majority of what you'll see with the laws of exponents. Now let's have a look just briefly at the power quotient. So say we got a squared b cubed raised to the power of 2. Now we're going to distribute that exponent to both terms there. We're going to get a. We need to multiply because this whole thing is in parentheses. We're going to multiply the exponents this time. So a to the 2 times 2 is a to the 4th, and then b to the 3 times 2 is b to the 6th. Likewise, if we have a quotient in the middle, a squared b cubed over ab, and that's all raised to some power, say -1. Then we're going to distribute that exponent to both the top and the bottom, and we're going to be multiplying those exponents. So a to the 2 times -1 is a to the -2, negative squared. And b cubed that times -1 is b to the -3. And then on the bottom, we're just going to have a to the -1, b to the -1. Now we got to flip this thing upside down because we got all negatives on the top and bottom. And we get a squared. Oops. We get ab on top, and we get a squared, b cubed on the bottom. And then again, if we have a to the -n, or 1 over a to the -2, say, then we're just going to move that negative exponent just to the top. If it's on the bottom, put it on top. If it's on top, then we'll put it on the bottom. Wherever that negative exponent is, just move it to the other side of the division sign there. A squared. And sure enough, that's the majority of the laws of exponents. There are also rational exponents, like x to the 3/2, which we can cover in another video. But for integer exponents, just remember that if you're multiplying or dividing like bases, a squared times a cubed, we're going to add those exponents, a to the 5th. And if you're adding or subtracting bases, whether like bases or unlike bases, then you cannot add or subtract the exponents. And if you end up with a negative exponent, then just flip that to the other side. If it was in the numerator position, flip it upside down, put it in the denominator. If it was in the denominator, flip it up to the numerator. All right, this has been Laws of Exponents of Dr. T's Algebra 2. Thank you.